Hi, welcome to our pre-calculus. Today's topic is sketching the graph of a tangent or cotangent function, problem type 1. So let's go ahead and review what we did last time. We talked about the graph of all 6 trig functions, in particular tangent and cotangent. We said several things. Let's go ahead and review that. One is vertical asymptotes, where the function goes to infinity because we are dividing by 0. So tangent, you remember, was sine over cosine. Cosine becomes 0 at multiples of odd multiples of pi over 2. As a result, at pi over 2, 3 pi over 2, minus pi over 2, and so on, we have vertical asymptotes. We explained how the graph looks like this stretched curve. We mentioned the period of it is pi. Let's add a couple of more detail to our pictures. One is the tangent of pi over 4 is 1, and tangent of minus pi over 4 is minus 1. And this feature repeats itself every pi. So every pi that you add to your pi over 4, you still have tangent is equal to 1. And every pi that you add to your minus pi over 4, let's correct this thing, this was minus 1. So tangent for example, 3 pi over 4 is also minus 1, and 7 pi over 4, and so on. For cotangent, we had a similar picture, except that the vertical asymptotes at multiples of pi, x-intercepts at odd multiples of pi over 2, period is still a pi, cotangent of pi over 4 is 1, and cotangent of minus pi over 4 is minus 1, and it repeats itself every pi. Okay, so we just have these two, secant and cosecant, somehow pushed to some other section, and we go ahead and look at problems type 1, which simply means what? We are going to multiply. So what is happening here, instead of just being an x, it's a multiple of x, and instead of just having 1, we have some multiple here. Now tangent and cotangent, we notice that they're kind of featureless, slippery curves. They don't have as much easy points to handle like sine and cosine, which had the maximum minimum. If you notice that in each of these blocks the curve simply just goes up. From here to here the curve just goes up, and for cotangent it just comes down. So we don't have a maximum minimum to point at, and for that reason your software is asking you to track the following. So we are going to track the asymptotes. We are going to specify where the asymptotes are. We are going to specify where the intercept is, and halfway point between these points, like pi over 4 and 3 pi over 4. So the 5 points to consider for cotangent are the following. We are going to track 0, pi, and pi over 2. We are going to have vertical asymptote at 0, vertical asymptote at pi, crossover at pi over 2, halfway point, which is pi over 4 and 3 pi over 4. We have our 1 and minus 1. Similar thing for tangent, except that we are going to go, if you want to stay between the two asymptotes, we are going to go from minus pi over 2 to pi over 2. The crossover is at 0, and our halfway points here as, like, for example, minus pi over 4 and pi over 4. Of course we could have looked at any other block and do the same thing, but these are kind of standard blocks for us to check. So the 5 points that we are tracking are these, unlike what we did for sine and cosine. So since the period is just pi, we have to do everything within a pi period. So cotangent of 3x. So 3x, let's make a table. So we have 3x cotangent of 3x. So cotangent, we're going to go from 0 to pi. So 0, pi over 4, pi over 2, 3 pi over 4, and just pi. Okay, cotangent of 0. Now notice we have a little bit of a issue here. At 0 itself, we go to infinity. But if you go look at the other side, you go to minus infinity. So we have a kind of a split personality at 0. On one side of it, like a Gemini, on one side we are all the way up, on the other side we are all the way down. So we are going to label it like this. We are going to stay inside our block by saying that on this side we are at 0 plus, and for this one we are going to say we are staying short of it. So I am going to write pi minus, meaning I am to the left of that pi. Is that right? So I'm staying inside that block. So 0 plus means I'm on the right of 0. Pi minus means I am at left of pi. So what happens at 0 plus? At 0 plus I come all the way to infinity. So my picture is going to go up. At pi minus, my picture is going to go to minus infinity. Now, of course, Alex or no other software has any way of actually catching or pinpointing anything at infinity. That's the point of infinity. You can never stand anywhere and say, well, I'm standing on infinity. So we are not going to be able to graph this. It's just going to be indicated. Instead, what the software is going to do is track these 3 points, and by that activity, it's going to know if it is going to go up or down or how. Same issue here. So here we have pi over 2 on the left hand side of it. Pi over 2 minus means we are on the left of it. Minus pi over 2 plus, now that's going to be a little cryptic, means that we are on the right side of that asymptote. So with that description, let's go back here. So by 0 here we mean 0 plus, and by pi minus we mean on the left side of pi. So cotangent here is going to be plus infinity, and here also going to be minus infinity. So what happening here? We are saying that inside this block, let's see, what, maybe that's a good color. We are aiming at this block. We are starting at plus infinity and ending up at minus infinity. That's what we mean here. Okay. At pi over 2, that's our crossover point. So that is just 0. This is going to be 1, and this is going to be minus 1. So 1 and minus 1 here are referring to the first cotangent of pi over 2 is 1. Cotangent of 3 pi over 4 is going to be minus 1. Okay, so what is it that we are trying to graph? We are trying to graph 1/2 of this thing. So it's 1/2 of cotangent of 3x. So 1/2 of cotangent of 3x. Half of infinity, of course. Like if you're a billionaire and you divide your money by 2, you're probably still a billionaire. So 1/2 of infinity is infinity. This is half, 0, minus half, and also if you are in infinite debt and somehow half of it is forgiven, you still are in infinite debt. So x is going to be a third of these things. So 0, pi over 12, and pi over 6, and 3 pi over 12. Again, we're just dividing all of these things across the board by 3. Like we said before, it's a little bit more comfortable if you have the same denominator. So 0 just doesn't need any denominator. This is pi over 12, and this becomes 2 pi over 12. And this is, well, doesn't need anything, 3 pi over 12. This we multiply by 4 becomes 4 pi over 12. We are multiplying numerator and denominator by a number so that we have the same common denominator across the board, so that helps us. How does it help us? Well, you see, we have pi over 12 labeled for us as, so this is, let's go now, let's just, for whatever reason, this picture has 2 blocks of it is pi over 12. Okay, now we are going to draw 2 asymptotes for us. Where are the asymptotes going to be? Asymptotes are at wherever we are going to infinity, as 0 and pi third. We are going to go to so we have an asymptote here, and the other asymptote is pi third. This is already conveniently labeled for us on the horizontal axis, so the activity we did here perhaps is not helping all that much, because the software is helping to label everything already for us. So let me maybe make it look like software. 3 pi 12, you can write it as, of course, pi fourth. So we have the other asymptote happens at pi third, or if you wish, if the horizontal axis wasn't labeled for us, then 4 pi 12 we would have used it. But in this case, we are lucky that the horizontal axis is already labeled, so I see that this is the other asymptote. So this is the vertical asymptote, this is the vertical asymptote. Then we have the crossover point. Crossover point is at pi 6. So pi 6 is luckily just for us here. In case it wasn't, we would have used this value to help us count the number of blocks that we have and figure out where our crossover is going to be. Well, yeah, this question asks us start by drawing 2 asymptotes, and then between these asymptotes plot 3 points. A point where the graph intersects the x-axis, so that is where it is. So there's 2 asymptotes. This is what is referring to. Intersecting the x-axis, well, that is just our x-intercepts, is that right? And then a point to the left, a point to the right. What does it mean? Well, that's we are going half to the left, half to the right, meaning this points at which we have easy access to what the value of the function is, pi over 12 and pi over 4, or 3 pi over 12. At these 2 points, the value of the function is going to be half or minus half. So a point to the left, that's what it means, and a point to the right, that is to the right of that midpoint. Well, after you have done all of that, the graphing is actually left to the software itself. It's when you click on this, you are going to see the graph being filled in for you, so it draws something like that's what we expected to draw for us. Okay, so let's go ahead and make it a little bit less so this is the graph that we are after, vertical asymptotes and the x-intercept, and a point to the left and a point to the right that we are after. Your asymptotes, of course, are placed by that vertical line. You can get your points by clicking on it or by using point plotter. Point plotter, you remember, you have two entries, you enter x and y, and so we have your x, for example, here, and this is the y of it. This is the y value you're supposed to enter. Let's go ahead and do some others. Minus 3 times cotangent of 2x. So let me make my table. So I have cotangent of 2x, and then as usual 0, pi over 4, pi over 2, 3 pi over 4, and then what, pi cotangent, so it's plus infinity 1, 0, minus 1, minus infinity. We have a multiple of minus 3 here, so minus 3 cotangent of 2x. So minus 3 times plus infinity. What does that mean? Minus 3 times plus infinity. It's minus infinity. Minus 3 times 1, that's easy. 0. Minus 3 times minus 1, that's plus 3. Minus 3 times minus infinity is plus infinity. What does that mean? This means your function is flip-flopped. You're going to see. And then you go to calculate your x. So x is half of this, so it's easy. Pi 8, pi 4, 3 pi 8, and pi over 2. So we learned our lesson last time that well, in these problems the software is becoming extra helpful to us, and it's stretching the picture on the horizontal quite a bit more than what's expected. So two asymptotes. The asymptote is 1 at 0 because it becomes infinity. 1 at this is vertical asymptote. Function is minus infinity, means that we know it is going to go down here instead of going up. The other asymptote, where is the other asymptote? The other asymptote is at pi over 2. These are the location of the asymptotes. So I'll go ahead and I do the other one. Pi over 2, how do I do it with this one? Then on the left of that asymptote, I'm at plus infinity. So again, this is remember we talked about those pluses and minuses, so I'm expecting my picture to come up here. Halfway point we cross over. Halfway between the asymptotes and the crossover point, we are going to be what? We are going to be at here. We are going to be at minus 3. So minus 3 I will be down here, and plus 3 I'll be up here. So where did I get the minus 3 from? Minus 3 and pi 8. Pi 8 is pi 8 and minus 3. The other one is 3 pi 8, 3 pi 8, and plus 3, so that's going to be here. So the picture now, well, we are not, the software wouldn't have enough room to, so it's going to be like this. It's really like this. Well, perhaps a little bit nicer than what I did. Let me see, I can do a better job of this. So it takes a bit more space for it to approach its vertical asymptote. So if this keeps going, the visibility of the asymptote is going to be improved. So your software will draw that for you. So these are the points that you click, and these are the asymptotes that you nail down. So this is the vertical asymptote, and this is a vertical asymptote, and that's the picture. In the language of transformations, what's happening? Two things. This factor of 2, remember the cotangent function was going between 0 and pi and look like this. Is that right? That was the graph of basic cotangent function. Now pi, because of factor of 2, we are going to be compressing this thing to half of its region. So it's going to be compressed to 0 and pi over 2. So that's where this is. Now it got hidden here. This is pi over 2. And in the software it's expanded so that you can see it, but we are reaching our asymptote at pi over 2. Factor of 2 earlier than expected because of this factor of 2. Next, it is 3 times as tall because of factor of 3. So we are taking this and making it 3 times as taller. So 3 times that taller will be looking like this, 3 cotangent of x. And then multiplying by minus makes it flip upside down. So it's going to look like this. Minus 3 cotangent of x would have been like this. And then having 2x makes everything compressed. So understanding the transformations is just as important as just this point plotting. Let's go to do another one. Okay, this one is tangent. Tangent of minus 1/2 of tangent of 1/2 x. So let's make our table here. So our angle, input angle, is 1/2 x, and we are taking tangent of this, tangent of 1/2 x, and then once we are done with that, if we are multiplying by minus 1/2 tangent of 1/2 x, that's what we are graphing at the end. And of course we need our x to function. So for tangent, if I want to have it, again says draw 2 consecutive asymptotes, and the way it is laid out, we are just limited to the original left and right asymptotes. There are lots of them. The window of that software just has these 2 available to us, not the whole set. Okay. Where is it? It's from minus pi over 2 to pi over 2, and then we have we said we have these 5 points to track. We have these 5 points to track. So let's go ahead and so minus pi over 2, minus pi over 4, 0, pi over 4, and pi over 2. These are what we are tracking, tangent of these things. Okay, so slightly to the right of this asymptote, this is going to be minus infinity, then we are going to hit minus 1, then 0, then 1, and then plus infinity when you're hanging to the left of this. Okay, so what does that mean? Minus pi over 2 plus. You remember the discussion we have here. On the right of this line, we are at minus infinity. We are down here. On the left of this line, we are at plus infinity. Okay. Then we are multiplying by minus half. Minus a half. Remember, negative times negative becomes positive. That still applies to infinities as well. So this becomes plus infinity. That means it's going to flip. This one becomes half, 0, minus a half. Minus half times plus infinity is going to be minus infinity. The original x's are half of these x's, so it's going to be minus pi over 4. excuse me, big mistake. 1/2 x is equal to minus pi over 2. So the original x's are double of these, so it's going to be minus pi. Is that right? So I made a mistake. Let's correct my mistake. 1/2 x are these basic angles, and then x is going to be double of those. So if 1/2 x is, say, for example, minus pi over 4, then x is going to be minus pi over 2. So minus pi over 2, and then 0, of course, pi over 2, and this is going to be of pi. So what does this mean? It means our picture is stretched by a factor of 2. So we are starting at minus pi. So one vertical asymptote is here, and one vertical asymptote is here. At minus pi, I'm at plus infinity, means my picture eventually going to start up here. At the other end, my picture is going to go down here. So that's what I expect to happen. Not that I'm going to draw it on this software. It doesn't have that much flexibility for me. I have a crossover point that is here at minus pi over 2. At minus pi over 2. I am at 1/2 at minus pi over 2. I am at 1/2, so it's going to be on the vertical axis. The picture is not stretched enough for us to have visibility. So if I were to suggest some improvement, would be to stretch this a bit. Anyway, so at pi over 2, at pi over 2, we are at minus 1/2, so which is going to be down here. So where is the picture going to look like? Picture is going to look like this. So you draw these with the help of the line grapher. Then you pinpoint these 3 points with your pen or with the point plotter, and then once it's all done, you ask the software to fill in the detail, and that's the picture we expect to get, and so on. So this is minus 1/2 of cotangent of 2/5 of x, so peculiar numbers. So minus 1/2 of cotangent of, what was it, 2/5 of x. That's what we want to draw at the end. So of course we start with cotangent of 2/5, and that is input of 2/5 of x, and then we need x. So for cotangents, what are the 5 numbers that we track? For cotangent, we said these are our numbers. We go from 0 to pi. Remember that, 0 to pi. 0 to pi for cotangent, so we are going to go from 0 to pi. Of course, halfway point, that's our intercept. Quarter points, where so cotangent is going to start at plus infinity, hit 1, hit 0, hit minus 1, go to minus infinity. If I'm multiplying by minus 1/2, I wish that's written like, say, minus 3 or something. Anyway, so it's minus infinity, minus 1/2, 0, plus 1/2, plus infinity. Is that right? Now, let's be careful here. 2/5 of x is any of these angles. So what is that angle? So 0 is 0. So if 2/5 of x is pi over 4, so what is x? Divide by 2, so it becomes 8. Multiply by 5, so 5 pi over 8. So that is a peculiar angle, huh? So now another one, 2/5 of x is going to be pi over 2. So x is 5 pi over 4. 5 pi over 4. 3 pi over 4. So 2/5 of x is 3 pi over 4, and so that means x is 15 pi over 8. And finally, if 2/5 of x is equal to pi, then x is 5 pi over 2. 5 pi over 2. Let's see, maybe this time we actually benefit from cleaning this up somewhat, because on the horizontal axis we don't see these numbers, and so common denominator is 8, so 0, 5 pi 8. Multiply this thing by 2, so 10 pi 8. Multiply this by, well, nothing, 15 pi 8. Multiply this thing by 4, 20 pi 8. So the block that we are going every time is a 5. We are going 5 blocks of each block is pi over 8. We learned from here. This is the block pi over 8. We better keep track of that. So if this is pi over 8 is this block. Pi over 8 is conveniently that block. This is pi over 8. Okay, before we go blind trying to figure out where everything goes, it's pi over 8. So we are going from 0 to pi. That makes our life excuse me, we are going from 0 to 5 pi over 2. So 5 pi over 2, we draw one asymptote here, 0 to 5 pi over 2, 0 to 5 pi over 2. Halfway point is going to be what? So halfway point is going to be 5 pi. This is a half point, 5 pi over 4. It's not labeled. It's 10 pi over 8. So I'm going to count or just eyeball it, halfway points. So up to here, I'm going to have 10 blocks. So this is 4 blocks, 4 blocks, another 2 blocks. So here I hit the middle. Is that right? So let me clean this thing so that it doesn't. Then 5 pi over 8. Here, 5 pi over 8. That's where we are going to hit minus a half. Well, 5 pi over 8 is going to be this location. This is 5 blocks here. I'm going to be minus a half. So that's what I want it to be stretched a bit. So this is minus a half. You have to click there, and 5 blocks over, that's going to be plus a half. So this is going to be a picture that we are going to have. So after you have these 3 points, you click the presumably you're going to get something like this. This is graph of minus 1/2 of cotangent of 2/5 of x. So notice that the horizontal axis wasn't conveniently labeled for us this time. We had to go around and figure it out ourselves. Okay, I guess this is. So you notice that it's a bit nitty-gritty detail. It's a good practice for you as to go when you go to calculus. There's going to be all sorts of functions, not necessarily well known as tangent or cotangent, so you would need or there to recreate everything from scratch for yourself. Here we had a blueprint. We had tangent and cotangent already drawn for us, and we just stretched it one way or another. What you are going to do calculus is the entire thing from get-go to the end has to be created from scratch. Okay, let's have that. We are all getting ready for that. Until next time, good luck and God bless.